Hi there, I'm Alex Evans. I'm here to talk to you about vertical takeoff, vertical landing rockets. Primary idea behind these is all in the name. They take off, they kind of do their work up here, satellite drops, International Space Station resupply, data collection, and then, those two parts are kind of lost, and this big booster is guided back to Earth safely to be reused. You might be curious, you're wondering, why would someone work so hard for that? Mainly, it's going to reduce costs to space exploration. It's going to make it more available. You've got SpaceX, this private kind of space company that's working and developing a lot of these technologies. Furthers exploration, it's going to reduce the cost. It's really freaking cool. And a lot of the time, these boosters can't get back to land, so they're going to have to land on a barge in the ocean. Main idea behind this: rocket takes off, it climbs, there's this stage separation. We lose the two stages up here. They're dropping satellites, they're dropping water to the ISS. Booster stage that we're following has to execute a flip because its nose first needs to land feet first. After it does this, it enters the more air resistive area, dense air, so it can use fins to kind of guide itself and a deceleration burn to slow down before it does some fancy movement right before it lands on the barge or a solid ground kind of thing. How is a major question with this, right? So up top, when there's low air resistance, low air density, it's going to use these gas thrusters right after separation to whip that flip around. When the air starts to thicken up, it uses grid fins, which are just like latticed fins to kind of guide it, slow it, move it towards the barge. These guidance systems are always working, adjusting things. The low center of mass is really going to help these two things far away exert a large rotational component on it for relatively small forces. Landing gear, very wide, 18 meters. Wider base, more stable on that final moment when it's landing. Then it's got 9 massive engines that can point or vector their thrust just a little bit. Just going over some of the stages now. Separation, right when it pops off that first stage. It's got a velocity this way, but we need it to flip that way. So you're going to get some gas thrust. Here, pushing out moves the rocket this way, flips it. So it's engine first, foot first. Then, as it's falling, the air is going to thicken up here so it can deploy these fins. These fins just aren't like out or in. They can change, so that can kind of modify the way it flies. You've also got the deceleration thrust, like we spoke of earlier. It has to be greater than the weight of the rocket in order for it to slow down. So that's a pretty juicy engine. Then we're getting to the landing component. You've got the ground here. Maybe it's a barge. Maybe it's just a landing pad. These things really get some final adjustments to help get it upright. Landing gear is nice and wide, a lot of shock absorption going on. Then you've got these vectored thrusts, like it'll really shoot out to the side to kind of help move that. Think of like if you're balancing a broomstick on your finger, how you have to kind of move quickly to keep it up. And that's kind of it. So in summary, there's a lot of very cool technology and things that go on to make this happen. But now I'm going to leave you with, we have time for a little video of one of the failures where you can really see those top gases. They shoot out, try to adjust it. Lands kind of wonky, landing gear's not enough, and it's great. Thank you for watching. I hope you have a nice summer.